chemistry video. So today I thought we'd start with Snar reactions, and then here later I'll post an EAS reaction video. Now, Snar reactions are a lot simpler than EAS reactions in my opinion, and all a Snar reaction is a Snar reaction is a nucleophilic aromatic reaction that usually involves a leaving group and a specific electron withdrawing group. And we'll talk about those specific electron withdrawing groups and leaving groups here in the next couple slides. But before we do that, I implemented a little meme to brighten everyone's day, and it says, what's it called when you understand stuff in organic chemistry? Well, that, my friends, is called imagination. So moving on, let's look at some marine electronics when it deals with Snar reactions. Now, these are electron donating groups, and electron donating groups do not play a big role in Snar reactions whatsoever. We really care about the electron withdrawing groups. However, I thought I'd implement this because you're going to need to know this for the electron, or not the electron withdrawing, you're going to need to know this for the EAS reactions. And what I have labeled here is nitrogen, oxygen, and methyl. Now, methyl is going to be your least donating, then it's going to go oxygen, then it's going to go nitrogen. Now, methyl is the least donating because it donates via inductive properties. Oxygen, once again, can donate those lone pairs, and so can nitrogen into the benzene ring. And I also labeled the ortho and the para carbons because the ortho and the para carbons are where it's going to be electron rich after that donation. So moving on. Now the electron withdrawing groups. Now these are the guys that are going to make or break you in these Snar reactions. So these are the ones you really got to know. However, there's only two electron withdrawing groups that are actually important for our Snar reactions, and that's CF3 and NO2. All the others you can forget about for Snar reactions. They're not going to initiate a Snar reaction. But if you see NO2 or CF3, it can undergo a Snar reaction. And I also, once again, labeled the ortho and the para carbons where it's going to be electron deficient, not dense, but deficient, since these are electron withdrawing groups, not donating groups. So, the leaving groups that occur in Snar reactions. This is fluorine, chlorine, bromine, and iodine. Now, fluorine is going to be your fastest, ka-chow, because of that increase in electronegativity. However, if this was an SN1 or SN2 reaction, forget about this chart because for SN1 and SN2 reactions, it actually goes the opposite direction. But for Snar reactions, it actually goes this direction, which is very unique for Snar reactions. And this, once again, is only the case for Snar reactions. So only use this diagram and this chart for Snar reactions. For SN1 and SN2, it is the opposite direction. Iodine is your best leaving group for an SN1, SN2 reaction. However, for a Snar reaction, fluorine is your most fastest leaving group because of that electronegativity factor. I just want to emphasize that because I know people are going to get confused on this because in an SN1 and SN2 reaction, iodine is your fastest. However, for Snar, fluorine because of that electronegativity. So now let's look at some basic rules regarding Snar reactions. So there's only a select few nucleophiles that work in a Snar reaction, and those are negative OH, negative OR, and negative CN. And the R is just a carbon chain. I wanted to point that out. You're not going to see an R on an exam. You're going to see O-meth, O-et, something like that. And now then there are only two electron withdrawing groups that can initiate a Snar. Now that's NO2 and CF3. Like I said previously in the other slide, NO2 and CF3, only ones you got to worry about. All the other ones, forget it because they're not going to initiate a Snar reaction. Now the big rule to remember for Snar reactions is the electron withdrawing group and the leaving group have to be paired to one another. Now what that means is, say this is your halogen and this is your electron withdrawing group. They are para. If it was here, that would be ortho, or here, that would be ortho. If it was here, that would be meta, and if it was here, that would be meta. So the only two we care about is para conformation. So they're paired to one another. The halogen, or leaving group, and the electron withdrawing group have to be para in order for the Snar reaction to initiate. So now let's just take a look at some examples. So we'll start with this reaction, and I'll draw the mechanism out first, and the other ones will just actually predict the product without drawing out the mechanism every time. So how I like to do these is initiate my electron withdrawing group, which I will do in red, which is CF3. So we're good. This is a Snar reaction because it's CF3. We want to look at our nucleophile. It's OH, so yes, still a Snar reaction. It's ionic because of this Na. That's how that becomes negative. And then this is your leaving group right here, which I'll highlight in yellow because it is para to the electron withdrawing group. This is not our leaving group because it is meta to that electron withdrawing group. Now then, if we draw the mechanism out, it would look like this to get to your intermediate. That's your intermediate. Now then, once this happens, you would then have your nucleophile come in and attack that electrophile. This would leave. This would come here. This would go there. And this would go there. Oh no, that would not go there, my bad. Ignore that last step. And then you would get your final product. Which looks like this. And that is all you have to do for a Snar reaction. Not hard at all. You could also draw it with a circle in here. That would be efficient also, just to indicate that that's a benzene ring. That's how I like to draw them, so I don't have to draw all those lines. So moving on to the next reaction, what's going to happen here? Well, we have OET, so it is an OR with a negative charge. So we can say it is going to be a Snar reaction. We have a leaving group and an NO2, which is a good electron withdrawing group, para to one another. So that's going to be your electron withdrawing group. This is going to be your leaving group. And when they leave, all that's going to happen here is this. So nothing too fancy. It's actually a pretty simple mechanism. So moving on to our final example. So I actually have these all labeled out already. You have CO, you have fluorine, you have CF3, and you have O-methyl. Now, O-methyl is going to be a donating group, so we can just ignore that. Even though it is paired to fluorine, that's not going to be what initiates the Snar reaction. It's going to be the CF3 that's paired to the Cl. CF3 is your electron withdrawing group, and Cl is going to be your leaving group. LICN, this is ionic, so we can label this as negative. That's going to be your nucleophile, and that is a nucleophile that can initiate a Snar reaction. So all that's going to happen here, oh, did not mean to do that actually, here. And that's your final product for that one. And that's all I have to get today, guys, for Snar reactions. They're not that hard to follow. The next video will be on EAS reactions, which they have a lot more roles and they're actually a lot more complex. But if you get the hang of it, they're not as bad as you think they'd be. So have a wonderful night.